Hello, algebra students. So we're starting chapter 6, radicals. And radicals are just the square root or cube root or fourth root or so on of a number or a variable. And we're going to be doing a lot of different things with radicals in chapter 6. In chapter 4, we actually worked with radicals to get ready to do the quadratic formula because it has a radical in it. And so we actually simplified radicals in chapter 4, which is what we're going to do today. So this part is review, but we will go on from there and be doing a lot more with radicals. So this is section 6.1, simplifying radicals. We have the notes here that we're just going to go over and then do some examples. So you have here the nth root of a is how we read that. Okay, the nth root of a. N is the index, and that is the degree of the root. Oftentimes it's 2, and we call that the square root, but it can be any number 1, 2, 3, and so on. Okay? The radicand is the number inside the radical sign. So that's the a. Okay. So we'll look at this example, and we read this as the square root of 4, right? That's pretty familiar. It has no index number, so that means it's a square root. When you don't write the index there, it's understood that it's 2. So it says here the square root of 4 and square root of 4 are the same thing. I read that the same way even. You have this radical with no index, and you have the one with the index of 2. They are the same thing, and we call it the square root of 4. And so what is the square root of 4? Well, we have it here. The square root of 4 written without the index is the same thing as square root of 4 with the index. And what is that? It's 2. Okay? Because 2 times 2 equals 4. So it's the number that times itself when multiplied just 2 times equals 4. Okay, and that's because of this 2. We're looking for the number that multiplied twice equals 4. And so the cube root of 8 equals 2. Cube root being the radical with the index 3. Okay, that's 2 because 2 times 2 times 2 here, 3 of them multiply to 8. So you have 3 multiplying because the index was 3. Okay, whatever number when multiplied 3 times gives you that radicand. Okay. So we look at the fourth root of 81. What's the fourth root of 81? It's 3, because it takes 4 3's multiplied to make 81. So if you have an index of 4, you're looking for the number that multiplied 4 times gives you that radicand, the 81. Okay. So to simplify radicals, we use the cake method. And here it is. And we did this back in chapter 4, as I said, when we were simplifying radicals to get ready to work with the quadratic formula. Step 1, divide the radicand by prime numbers until you get a 1. That's a candle on top of the cake. So you keep dividing by prime numbers, then the answer is divided by a prime number, and then that answer is divided by a prime number, and so on until you just get to 1. And then you use the index to tell you how many of each number there needs to be to make a group. In the ones we did, it was always 2. We were always doing square roots, so the index was 2. Take one number from each group to pull out of the radical, and any number left over without a group goes back into the radical. Okay, so it'll make more sense when we look at some examples. So let's do that. So bring in the second page of notes, and we will do these problems. Okay, so let's look at example 1a. Simplify, and that's just the square root of 80. Okay, so we said we divide by primes until we get that 1 on top of the cake. When we did them, we actually did a sort of upside down cake when we did it, which is handier in some ways because you can start at the top. We did the 2, and then we did 40 here, and we kept going down. But that doesn't look like a cake. And so on. That's sort of an upside down cake. This time I'm going to go ahead and do the cake right side up. And that just means you have to sort of guess where to start, because we're going to go up. So this looks about right. So 80 is the number. We're going to divide by a prime. Well, 2 is the obvious one, right? So that's 40. Divide that by a prime. We'll use 2 again. That's 20. Divide that by a prime, which we'll use 2. Gives you 10. Divide that by a prime. We will use 2 again, and then we get 5. And then to divide that by anything, it has to be another 5. And then you have a 1 on top. 5 divided by 5 is 1. Now when we did this method, we didn't actually go all the way to the 1. We just stopped when we got this 5 here. And when you then divide that by a prime, you're going to get the same 5 again. Okay, so we counted, again, this 5. Let's see, I'll show you what I mean. This 5, we counted it as one of the primes. We don't want to do that now because we went ahead and divided it by 5 and got that prime out there. Okay, so this way we only count what's outside. Okay, this 5 counts, but the one in there does not. So let's look at this. We group these, and we group them in groups of 2. And you're used to that from chapter 4. But now you know the reason why we use groups of 2. It's because this index was 2. We don't write the index this time. It's optional because when it's 2, you don't have to write it. But that's what the index is. So we look for groups of 2. We have a group here. We have a group here. And that's all the groups of 2. Okay, so for each of those, we write down a 2. The way it's put in what we just read was you take a 2 out of each group. You take a number out of each group. So we have 2 groups, so that's 2 of the 2's that go outside the radical. What goes inside the radical is the leftovers, which is just, okay, that 5. That's all. So that goes inside. If there were more numbers inside, we would multiply them by each other, right? So all we have to multiply, though, is what's outside. 2 times 2 is 4. And inside it's square root of 5, and that's it. Okay? Let's look at the next one. So we're going to make our cake 196. Well, we'll use 2, and that's 98. We can use 2 again, and that's 49. Okay, and that, the only thing that goes into that is 7, which gives us another 7. And if you stop there, you say this 7 that we just put on there is one of the primes. But again, we're not going to stop there. We'll go ahead and do it the way they say. Divide that by 7 to get 1. And now let's look for our primes, and we're again not counting that one inside. So we look at our pairs. We have a pair here, we have a pair here. So those come outside the radical, and we have a single pair of 2s, so that gives us a single 2 out here. We have a single pair of 7s, so that gives us a single 7 out here. There's no leftovers, right? The 1 doesn't count as a leftover. It would just be the square root of 1, which is just 1. So we have 2 times 7 on the outside, nothing on the inside. So that is our answer. Okay. So in 196, it turns out, is a perfect square, which if you knew that, if you've learned the perfect squares up to, about 20 or so, which is kind of a cool thing to do, then you would know that. Okay, let's look at the next one. Now, this is a little different. These first 2 just had the radical. This has a number outside the radical as well. And that doesn't really complicate things much. When we finish simplifying the radical, we'll have a 3 multiplied by it. And we just do any multiplication. If there's another whole number, we'll multiply the 3 times that. Okay, so we make our cake of the 150. We need to start down here to give ourselves room. So we'll start with 2. And that gives us 75. 150 divided by 2 is 75. And we can't keep using 2s this time. We're done. No more 2s. So we have to do something else. So 75 and 5 is what we can use. 75 divided by 5 is 15. And we're on a roll with our 5s. We might as well use 5 again. We get 3. Okay, we're not going to just leave that 3, so we say 3 goes into 3, and that's 1 on top. Okay, so we look for pairs. The only pair we have is this. So a 5 goes on the outside. We have 1 pair of 5, so a 5 goes on the outside. We also have 3, of course, on the outside because that right there. Okay. And so you have 3 times 5 on the outside. The 3 came from already being there. The 5 came because we have a pair of 5s when we do the prime factorization. What goes inside is that 3 and this 2. Okay, so that goes inside 3 times 2. Okay, so on the outside we have 3 times 5, which is 15, and on the inside we have 3 times 2, which is 6. So that is it. Okay, so now we're going to look at some of these with variables. We did not do this in chapter 4. So you do it the same way as far as the numbers. But then the variables, we have to deal with them as well, right? So let's just cake this number, as we say. That's a 45 that's inside there. So let's do that first. So we can use 5. We have 9. 45 divided by 5 is 9. And then all we have is 3, right? So 9 divided by 3 is 3. That gives us 3. Divide that. The only thing we can use is 3, and that gives us the 1 on top. So we look for pairs, and we have a pair of 3s here. But while we're at it, we're going to also look for groups in the variables. So the factors, with the numbers, the prime factorization is the factors, 5, 3, and 3. But with numbers, with variables, the factors are the variables. So we have this x to the 4th. Well, what's the factors that makes x to the 4th? X times x times x times x, 4 of them. Okay, and we have y squared, y to the 2nd, so that's y times y, and we have z times z times z. Okay, so we look for pairs in those factors. And we're looking for pairs. Our groups that we're looking for are groups of 2 because our index is 2. So just say, okay, there's a group of 2 x's. There's another group of 2 x's. There's a group of 2 y's. There's a group of 2 z's. And from each of those groups, we get that variable on the outside. So looking at the numbers, we have a 3. Okay, we have a group of 3, so that means we have a 3 on the outside. Just one 3, because there's just one group. So we look at the x's. We've got 2 groups of x's. So we could write it like that if we wanted to, x times x, 2 of them, but we write it with an exponent. Okay? And then we have a single group of y's, so we have a single y. We have a single group of z's, so we have a single z. And that's everything that's outside the radical. So what's inside the radical? Well, it's the leftovers. When we did the prime factorization, we had a group of 3's, but the 5 doesn't go in any group at all. So 5 goes inside. And then we have to look at the variables as well. Do we have any leftover variables that were not in a group? And yes, we do. It's this z right here, right? That's not in a group, so that goes in the radical as well. Okay, let's look at b. We're going to cake this 12. We use the prime of 2. We like to use 2 first. I'm not sure why, but then we have 6, divide it by 2, and we get 3. Divide it by 3, and we get 1. So primes is just this 2, 2, and 3. We're looking for groups of 2 there, so we have it right there. This group of 2. I just noticed something. This problem is not written very well. We are intending this to be square root, but it's not written that way. Now it is. Okay. So we get our blue back here in a second. There we go. Okay. So as far as numbers go, we took the 12, we caked it. We have the 2 that goes outside. And we know what goes inside. It's going to be a 3, right? Because that's the leftover that's not in a group. But we got to look at the variables. So we see the h, and it's to the 4th power, so we can write 4 of those down. we have j, that's to the 5th power. So if we have 5 j's like that, and so that's all the factors of the j to the 5th factored into these 5 j multiplied 5 times. And we also have k, and it's 3. Okay, so now we have to, look for groups there, and it's groups of 2, because our index here is 2, remember? So we have a couple of those h, and we have a couple j's, and we have a group of 2 k's. So one from each goes outside the radicals, so that's a single 2, one from that. And then we have h, we have 2 of those, right? Because we have 2 groups of h's. Okay, so that's h squared. And j, we also have 2 groups of j's, so that's j squared. Then we get inside the radical. What's left over? Well, this 3 was left over, right? That's not part of a group. So we have 3. And then the other things that's not part of a group are the variables that are left over down here. And you see we have a j that didn't make it into any group of 2, and we have a k. So those go inside the radical. And that is it. Okay, so one more. Okay, well, you know the drill. We're going to cake that 20. Okay, divided by, it's not a square root symbol, it's divided by. Okay, we'll use 2, and that's 10. And what goes into that? 2 gives us 5. 10 divided by 2 is 5. What goes into that? Well, 5. And the answer there is 1. And that's the top of the cake. Okay, so we can see our group of 2 2's. And we have a 5 that will go inside. But we also need to figure out these variables. So let's look at that right here. Well, we have u to the 3rd power. And so that's u times u times u. There's no way to get away with not writing all of those. You can't say, well, I think a couple of them. It's 3 of them, okay, because it's to the 3rd power. Okay, so, and then for v, we have 4 of those. Okay, because it's v to the 4th power. So we're looking for our groups, and we have 2 here. Then for v, we have a couple of groups. And so now let's put this all together. On the outside, we have, for each of these groups, we take out 1. So we have a single group of 2's, so we take out a single 2. And also outside, you have a u, because we have that group, right? And for v, we actually have 2 groups of v. So we got 2 v's out here, 1 from each group, and that's v squared. So 2u v squared. Inside the radical, you have this 5 that was left over, and then you have this u that was left over, so 5u. Okay, so that's simplifying radicals, but we're only looked at square roots today, right? We looked at ones that had an index of 2. So we will look at them with other indexes tomorrow. That's all for now.